here is the quick and easy workflow of doing it. So the first step is you baseline your system state. Figure out basically what is good in your environment. It's kind of a snapshot. I'm not talking about like a virtual machine snapshot in your VMware or whatever you're using. I'm talking about something at the application level inside of the virtual machine that you're doing analysis in. Then you start auditing what's going on in this VM. You monitor and log what's going on at the application level with processes, network, etc. Then you launch your malicious payload, whatever it may be, an executable, some sort of Word document or PDF, whatever. You let it do its thing for a little while. Hopefully it's done its malicious thing. Sometimes it won't. That's when you get to do more advanced stuff. And hopefully new processes have popped up that are doing bad things on your computer. So you suspend those processes so they stay in memory, and you dump their memory so you can look at it later. And sometimes these processes can kind of get in your way. So I've seen keyloggers that will actually get so hooked into the keyboard driver that each time you press a key, it takes 1 second for the letter to show up. Very annoying. And then you stop your monitoring. You've got all of the data that you need to do analysis on, and now you take a look at what you've captured. So hopefully after doing this a couple times, you begin to see some patterns and you identify what stands out. And then you have an idea of where to go look to see what it's done. And if nothing has stood out, then you can go back and compare your new system state to your baseline you took back at step 1. So to complete those things, here are the essential utilities that I use. For that system baseline of snapshotting what's going on in your system, I like to use regshot and auto runs. Regshot is basically a full registry dump of the entire computer, and it can optionally save off a full listing of the file system. And when it's all done, after you've run your malware, you run regshot again, you create another snapshot, and then it does a differential analysis on it, and it shows you what it was, what it is now, both in the registry and in the file system. Autoruns is a Microsoft sysinternals utility. It's out there for free. Kind of sort of the same idea as regshot, but it focuses exactly on places that Microsoft has identified software can be configured to come up on boot or when a user logs in. Outside of that, it doesn't really play with that stuff. So it's looking at services, run keys, etc. For general analysis, looking at Office documents, Word documents, Excel, etc. SourceFire wrote an app called OfficeCat. It's got something like 30 CVEs it knows about, and it has signatures for them. So you basically take that malicious document, bounce it off of OfficeCat, and it says, yes, I think this is malicious. Here's the CVE. And sometimes you can go look up that CVE and identify exactly what the payload is inside of it and how to pull that off and play with it. For a general purpose hex editor, I like to use McAfee's File Insight. It's got a really cool capability where you can select a region of your document and right-click and perform some transformation on it. So I use that for when I'm doing manual PDF analysis because you can have compressed JavaScript inside of PDFs. You can right-click and say inflate and then boom. Just inside that PDF, now you've got the decoded, deflated stream. And for packet capture analysis, Wireshark, everyone uses Wireshark. And pretty much anything by DDA Stevens. He's got a whole bunch of utilities for tearing apart PDFs. He's got utilities for looking at executables, looking at the certificates inside of them, and a whole bunch of general purpose command line apps. He's got an app called XOR Search that's mentioned in the Sans Graham class. You give it a string, and it tries to find that string XORed with any key inside that executable. So then you've got a key you can look at, and you go look for other strings in there. Great. For memory dump analysis, I like to use volatility. For an example on that use, I had a malicious Microsoft Word document that when I ran it, it crashed Word, started up a new copy of Word with a benign carrier document. Nothing else was changed in the registry or on the file system. No programs were started, no new files were dropped besides the benign document, the decoy. But suddenly my computer was infected and phoning out over the internet. So I said, okay, what happened? And I looked at it with volatility. I used the ConScan plugin that looks for artifacts in memory of currently running or recently completed, closed network connections. And I found out what happened is that Word document injected a new thread into explorer.exe, and that was then what was phoning home. So as long as I was logged in, this computer was going to continue beaconing out. For the auditing of what's going on in the system, OllyDebug and plugins, for doing dynamic analysis of the executables, IdaPro for static analysis of looking what's going on inside the exe, Procmon and CaptureBat. Those are the meat and bones of basic dynamic analysis. Procmon is what can log everything that happens to the computer in the file system, the registry, the network, new processes that started, exited, etc. And CaptureBat has sort of the similar capabilities of Procmon, except they can do a couple of things that Procmon doesn't. CaptureBat actually can intercept files being written to disk and save them off, or files that are being overwritten, or files that are being deleted. So if you've ever had something that downloads an executable from the internet, runs it, and then deletes itself, and you can't find it, CaptureBat's your guy for getting that stuff. It can also do a network PCAP at the same time and save all this off, zip it up, and give it to you in a nice wrapped present. So as a kind of system integrator by trade, I like using front ends to make my life easier. So David Hull, he's writing an application called AutoRunalizer. AutoRuns, like I said, is Microsoft System Internals. You can have it export a CSV file that has a SHA and MD5 hash of every program it's identified that is configured to come up on boot. In his script, he's got a shell script that works. What it does is it takes that hash and bounces it off VirusTotal, so you can really quickly identify something that's a known bad to the entire community. His Python version is a work in progress. He's still working on it. For Procmon, Procmon can export its data in XML. Otherwise, it saves it in a native format. I wrote a Perl script to parse that data and just give me nice, easy text tabular data so I can copy paste it into my ticketing system, look at it, see what new processes were launched, see what files were written by processes, see what registry keys were written by processes. That way I don't have to hunt around in a GUI. I'm a command line kind of guy. That's just the way I like things. So, all right, so virtualization, RAM efficiency. So let's say you've got 2 virtual machines in your VM host. Generally what happens is if you've got enough RAM, they kind of get stacked on each other inside of your VM host. There's nothing funny going on, they're just nice and comfy. So what happens if you try to run more virtual machines than you have RAM? That's called adding stress to your hypervisor environment. And what a lot of them do, almost all of them do this now, is they start deduplicating memory. So regions of memory that are exactly the same, for example, your NTOS kernel, your Explorer shell desktop, etc., they get deduplicated and merged down to 1 copy. And the things that are different, like say your Microsoft Excel or your Microsoft Word, they remain separate. So this ends up bringing back a lot of memory in your hypervisor environment. So now you can run an absurd number of virtual machines. This does come at a slight CPU overhead expense, because what this is doing is it's calculating a cryptographic hash of each page of memory for all of your virtual machines. So you can fit more VMs, it takes a little bit of CPU, and most times it's a tunable parameter of how heavy it's going to try to do this deduplication, scanning through RAM looking for duplicates. But this is what it's called in all the popular virtual machine technologies out there. Under Linux, it's called kernel same page merging. It's actually also used in Android phones. If you're running CyanogenMod, it's a tick box you can tick. That works on the Java Dalvik framework in there. VMware calls it transparent page sharing. It's a checkbox in both ESX and VMware Workstation. VirtualBox, they call it page fusing. That requires you to have a guest tool inside your virtual machine. So it's not exactly like globally accessible in every OS that you're running as a VM. And under Zen, it's called memory sharing. It's a technology preview. They don't really promote this. It's not really production quality stuff yet, but some of the basic stuff is out there. And if you have a situation in all of these environments where you had a whole bunch of exactly duplicate VMs and they started diverging their similarities, what happens is it doesn't crash. Your host that's running the virtual machines either takes those virtual machines' memory and swaps it out to disk locally, or through a driver usually, the host communicates to the guest and says, hey, I need you to take your RAM that you're not really using, and I want you to throw that on your virtual disk. So it swaps either on the host side or the guest side. So getting consistency and disk efficiency out of your VMs. So you've got your malware analyst. They set up their VM system and they start installing virtual machines. Then they realize that they need to run more than one virtual machine because they need to have different versions of Microsoft Office so they can run different malicious documents. They need to install different vulnerable software, and then they start installing their analysis toolkit. These virtual machines set up by each analyst end up being very different. They have different utilities on them. People have their own preferences. It makes it really difficult for one person to come across and say, hey, I'd like to help out because you're stuck, but you're not using the same toolkit that I use, so I'm kind of stuck. So the way I solve that is I use clones. So I've got virtual machine clones that I put on one centralized hard drive. I then export that hard drive image to all my analyst workstations, and then they can run their virtual machines from that system. But this kind of looks like everyone is running the same virtual machine at the same time off of one hard drive. That doesn't work. Operating systems don't like it when there's another operating system touching its operating system disk. It'll just write all over the hard drive expecting, hey, I own this disk, it's mine. And suddenly your virtual machine is all corrupt. So you can't have concurrent read and write to this one file system image. But there's a way around this. So, and you can export these these disk images to your analyst workstations either over a raw disk image protocol like iSCSI, ATA over Ethernet, Fiber Channel, or you can put it on an actual network file system like NFS, GFS, or Gluster. So to solve that concurrent read-write problem, I put those disk images on a read-only disk. Then that's same as usual, exported to my analyst workstations. They run their virtual machines from that, and then instead of writing back to that one read-only disk image, they write back to a copy-on-write disk image. And the nice thing about this is you can actually do multiple copy-and-write disk images. So if someone's running the same virtual machine time and time over, they have their own separate disk image. Oh, there it clicks. This ends up being an enabling process. If you put this shared copy and write disk image on shared storage, you can now move that virtual machine between analyst workstations. So if someone gets stuck doing analysis, they can just hand it off to someone else who's better proficient at it. You can still get your work done. If you put this copy and write disk image in a RAM drive, suddenly your snapshots become nearly instantaneous. No more do you have to please wait while we restore the system state. You can save and restore just like that. I did a snapshot sequence of like 7 of them at once, and they all saved or restored in less than a second. Because these disk images are just the changes to the file system, they end up being really small. So you can keep them around for a long time, and that can give you some additional things you can do later on down the line. So these copy and write disk images are usually referred to as lightweight disk images. VMware supports it in workstations called linked clones. It's basically a snapshot, and you tag that as a template, and then you create new clones off of that. In ESX, you can do that as well. They really want you to have VMware vCenter for the thin provisioning. You can download the VM from your ESX environment, tweak the config files, and then put it back up there, and it'll still work. It's just a little tedious. Xen, on the open source side of the house, I really couldn't find any information on lightweight disk images there. On the commercial side, I saw an XC clone command, so I think it's there, but I don't have the money to buy Xen. And VirtualBox, basically the same idea as VMware. And libvirt and QEMU, what I like to use, if you use LVM, it kind of can be done by hand, but there's the QEMU-specific image file format, QCOW2, that you can do this all manually. So what I did was I scripted this. So my malware environment is QEMU and KVM under libvirt. I've got the virtual machine disk images in an LVM logical volume. I set them to be read-only so I can't accidentally infect them. I was creating the copy and write disk images by hand, creating the disk images with this command here, QEMU image create, give it the backing file of the LVM volume, and point it at your file system that's in RAM. I found out, I was actually kind of paranoid for a while, what happens if my RAM drive gets full? I was like, ooh, you can't write to your disk, what happens? What ends up happening is the virtual machines all pause themselves. And the hypervisor says, okay, wait, you're stuck in disk I/O. You'll see all the VMs pause. Just go delete one that you don't care about and unpause them, and they all picked up where they left off. No sweat, no strain. So for my analysis environment, I've also got a man-in-the-middle like Linux box. It's my internet for the Windows analysis systems that I'm doing analysis on. I've got on there Apache IP tables for some redirection magic. So if something tries to go out to a website either by domain name or by IP address, it gets sent back to localhost on my Apache instance there. For setting up DNS and DHCP, I use DNS mask because you can say, everything is me. So no matter where you try to go, you're going to come see me. And I also have Samba on the man-in-the-middle box so I can upload and download files easily in the middle of me doing analysis. And the man-in-the-middle box is connected to both the malware analysis network and my live production network, so I can Say, for example, when I'm using WinDebug, I can reach the Microsoft symbol debugging server so I can see what's going on inside the kernel. So that environment I described earlier, where you had a whole bunch of people running virtual machines off of a centralized disk image, it's basically a cluster, but it doesn't have to be all that complex. It's pretty much already there in Fedora and any Linux OS that's got libvirt for its virtual machine management enterprise system. If you use the shared disk access stuff, you probably want to use something like the Linux software iSCSI target daemon. You want to make sure you use gigabit Ethernet, because if you're using 100 meg, saving that snapshot to that copy and write disk image is going to be slow, and you're going to get impatient, and that whole thing of having snapshots saved instantaneously over shared disk, it's a trade-off. It's not quite as fast, but you get the benefits of being able to shove that VM around to any system that you want. Again, clustered LVM for putting the disk images in there, and GFS for the cloud storage, copy and write storage. GFS is global file system. It's basically a block file system that you export as a disk image, and you can concurrently read and write to that file system. It's journaled between all the systems that are on it. When you create the file system, it's got some journaling systems, a set number of journals on there, so you can only have that many systems reading and writing at the same time. If the system that's exporting these disk images is also running virtual machines locally, you need to make sure you turn off the caching in the iSCSI daemon that's exporting those disk images. Otherwise, you'll get two different views of that disk image, and it'll end up getting inconsistent based on the local system and the systems coming in via over iSCSI. But this, like I said, this is entirely optional. You can do this all on one system. You don't have to set up this cluster stuff. So automation, making your life easier. So libvirt, that's your VM management platform. That's your start and stop, pause virtual machines, snapshots, and you can also optionally dump your virtual machine's physical memory for analysis with volatility. This is also where I create my clones. I take the virtual machine images, their configuration, it's an XML file. I pull out some attributes from there, tweak them a little bit, and then give it back to the VM management system as a new VM. And also for tweaking the disk images, for uploading or downloading data pre or post all of this analysis, I use libguestfs. Libguestfs is a really cool program. I think it's actually developed by Red Hat. It's a daemon that runs as a miniature Linux box that mounts your disk image and then does stuff to it. You can create file systems, format file systems, upload, download stuff. You can reconfigure things. I use this for uploading the malware sample that's initially what I'm going to do the analysis on to the hard drive and just drop it in SQL and malware. And during my analysis, I drop all of my analysis results in the same directory, and when I shut the VM down, I just download that directory, zip it up, and ship it up to my ticketing system. Another thing that's really awesome is libguestfs supports modifying the Windows registry. So if you're running a whole bunch of copies that are exactly the same of the same VM at once, they don't like that because they all have the same hostname, and they say there's a duplicate hostname on the network. So I use libguestfs to tweak that. This little hack of manually tweaking the registry works all the way from Windows XP up to Windows 8. I was actually kind of surprised. That part didn't change. So libguestfs also has bindings for C, C++, Erlang, Java, OCaml, Perl, Python, Ruby, pretty much any language that's of any value out there. So getting all this running, I wrote some Perl scripts that talk to libguestfs and libvirt. So I've got clonevm.pl. That's what takes that XML config, downloads it, tweaks it, puts the new config on the system, creates the copy and write disk image in RAM, and runs with it. Insert and extract zip, that's for uploading and downloading data from the VM. Peek.pl is what pulls out the virtual machine's physical memory, so I can do analysis with volatility. And ksmstat.pl is what shows how efficient the kernel same page merging in QEMU and libvirt is working. It's sort of similar to netstat or iostat or vmstat that you can see on your Linux boxes. It gives you basically the speed that KSM is running, how much RAM it actually has deduplicated, and how much wasted CPU time it's gone through memory trying to deduplicate the same page again and again and again. So collaboration and training. So usually when people are doing malware analysis, they've got one person sitting in front of one monitor on one virtual machine. If you have that virtual machine, its screen exported as a VNC display, you can use an application called VNC Reflector. VNC Reflector connects back to your display and then exports that display on a new port. This new port has a couple of new features now. You can have multiple people connecting at the same time, and you can also have different levels of access control. So you can have some people that are view only, like say, for example, classroom students, and you can have some people that have full control. So you have your instructors and your co-instructors. And because this is VNC, these people can be anywhere on your network. They can be in the same office as you, the same building, the same floor, a couple states over, maybe even across like the big pond, like in another country. All you need is the bandwidth for VNC, and you can interact with people over the phone or instant messenger, whatever. VNC Reflector also has another cool feature where you can take the VNC session, the raw protocol data, and just dump that to disk. So now you've got a video recording of a VNC session. So this is how you can do your screencasting and your playback of your analysis sessions. So I wrote another script called record VNC. You just give it the virtual machine name that you want to connect to, and you tell it, okay, I want you to show up on this new port. Then you have all of your friends, your coworkers, whatever, connect to that one port, and you give them their password of either the full control password or the view-only password. For self-service playing back virtual machine analysis sessions, I used RFB proxy. It can read that dump that VNC Reflector created, and if you put it in INetD, the INET Internet Service Daemon, now this playback system becomes self-service and completely separate to each person that connects in. If you just use RFB proxy on its own, it's got basically a carousel of different videos to play back. And if, say, one person connects in, they start watching video 1. If a second person comes in, they pick up where the first person left off. So that's kind of useless if you're trying to make this completely self-service, like a video jukebox. You can also hit a key or two on the playback, which is configurable to pause the playback and to skip to the next video. So for extra credit, you can take that video stream that was created by VNC Reflector, and you can convert that with RFB proxy to a PPM image sequence. So now with mencoder or FFmpeg or whatever other of your favorite video transcoding software, you can convert this to a video file that you can put on your iDevice, your phone, whatever. If you overlay that with some instructor audio, now you've got a training video. High quality, full resolution training video with no blurring of any kind. So what do you have now? So you've got consistent analysis virtual machines with efficient resource use of both disk space and memory space. You've got multi-participant, interactive, live training sessions. It's collaborative. You've got virtual machines that are thinly provisioned, efficiently using memory, disk space, and you can upload and download your analysis data and play with it as much as you want. The VNC sessions can be saved and played back at a future date. The actual raw VNC protocol file for about an hour's worth of analysis ended up being around 300 megs. When I transcoded that to MPEG-1, yeah, it's not H.264, it ended up being about 1.5 gigs, and that was me not doing any tweaking of it at all. So you can probably get this down to sub like 200 megs, maybe even sub like 100 megs. Okay, and the demo. So I'm going to play back a video I recorded earlier today. So this is a VNC session, full resolution, full video. I mean, there's no blurring from you using WebEx or any other screencasting technology. And I actually had a couple problems with the open source software RFB proxy getting this to work. I think under 64-bit, it tries to crash now if you try to skip to the next video. But it's open source, and I'm going to work on it as hard as I can. I'm not going to give up. I'm going to keep going on it, and I really wish I had sound. This is an artist you may be familiar with. I believe his name is Rick Astley. Yeah, sorry, I wish I could have sound in the VNC video. But, and now I'm going to do the cool part, running a whole crapload of virtual machines. Okay, so up at the top, oops. All right. Up at the top, I've got the Perl script I wrote to monitor how hard KSM is running. And KSM is not really doing anything right now because I don't have any virtual machines running. But I want to point out that my laptop here has 4 gigs of RAM. And it's got, I don't know, something really small used up. And I have swap turned off. So it's not going to do anything that's not in RAM. And here is the hypervisor saying it's using no memory right now because I have no VMs. So I'm going to drag this off to the side and start booting up clones of virtual machines. So you'll see them pop in over here. So start up the first VM, and it's going to use libguestfs there to upload malware samples or whatever, rename the VM, and now that VM is running. Oops, wrong one. So Windows XP coming up, and I've got a gig of mem used. And let's start another. And you'll see my memory usage is going up. And now KSM is doing stuff. So it's got 180 megs a second that it's going through. It hasn't done much deduplication yet, but so I'm still at around half of my memory used. I've got room for another VM. Oops. There we go. So I've got 3 VMs running now, and I've only got like a gig of something used. And now KSM is running through 400-something megs of memory a second, trying to deduplicate it, and it's pulled out, what is that, 2,000% savings? Or, sorry, 40% savings? Kind of hard to read from over here. And I've got 3 gigs of my laptop's memory used up. Let's go for some more. Still got plenty of RAM free. Let's go. Let's add some more. So how much memory does it say I'm running right now? On a 4 gig laptop? Says, as I pull it over, it says 6 gigs on a 4 gig laptop. And I've still got over half free. Isn't that kind of awesome? And the VMs actually do work. So, yeah, so they do work. And they're actually kind of responsive too. So, all right. Back to the video. All right, so next steps. I'd like to do some differential analysis of the virtual machines, pre-infection and post-infection of both the memory and file system. Basically, I'd like to identify new sections of code that are in memory, pull those out, do analysis on them, look for new variants of the same malware sample over time, create signatures, and then scan my entire enterprise network for looking for those. You can use something like Yara for that. It's a file-based signature system, and the volatility framework actually does support Yara rules. There's also some commercial IDS systems. I think FireEye supports Yara rules. I'd like to make this all these virtual machines web accessible through a web app where the VNC display is that Java VNC applet. I'd like to give you a capability to manage your snapshots, upload and download your files, and then hopefully at some point make this completely accessible over a VPN where anyone can get in these virtual machines and make it a service for my friends and coworkers. And I really like it when people do my work for me, so thank you, Jamie Levy. She is a badass in the volatility framework and Ncase. She wrote a script for Ncase that she called their differential N script. So remember when I said earlier about how the copy and write disk images are kind of small, so you can keep them around? This is how you can do differential analysis of the hard drive image pre and post infection. The malware can run, but it can't hide. So I don't know if you can read what it says on the screen there, but basically it's got two disk images. It's got the path to where the file was and what changed. So I think all of these on this system was new files are on a new file system. And like I mentioned, Nova Labs, I'm a founding member, and the reason why I mentioned it is because I'm going to run malware analysis classes there. They're going to start out probably in the April or May time range. You can expect the cost to be really dirt cheap. I want it to be affordable. Going to SANS classes or going to Black Hat training, that's thousands of dollars. I'm thinking somewhere between $25 and $35 per class. And I've already got a couple people that are helping me out come up with a curriculum. And I'm going to run malware samples that I find on VirusTotal and VirusShare, and even pull down some samples from Mila's contagio.blogspot.com website, where she's got, like, you know, those APT malware samples. Yes, drink. Yeah, so Nova Labs is in Reston, Virginia. So if you're local, please stop by. I've actually got beer glasses that we etched with a laser cutter at the hackerspace. For a donation of $5 or more, please be generous. You can have one of these glasses. Please see my man up here, Andy. He's got the glasses. I think I've only got around 10, but yeah. We've also got stickers that say Nova Labs on them, thanks to Joey. The whole idea of this, I want people to learn and teach and pass it on. So you want to know how to do this. So all of this is open source. I put this all up on my GitHub website. So it's werewolf, W-A-R-E-W-O-L-F. Yes, I know it's not how you spell werewolf. I was like 12 when I came up with that name. werewolf.github.com/thin provisioning. There's the automation code for spinning up the VMs. There's the documentation. I'm still working on it. It'll probably be uploaded by the end of this evening. And I've also got sample configs for the man-in-the-middle virtual machine. So with basically wiki instructions on how to set up the VM host environment and the man-in-the-middle box, you can get going in a couple days. So, questions?
Yeah, from the internet.
Oh.
Has the presenter considered live memory analysis using an introspection library like libvirt?
I haven't yet, but I don't think that this environment is counter to being able to use that. If you want to do some introspection of the VMs, you can do stuff probably with volatility framework. I don't think that they've got code for QEMU out there looking at QEMU yet, but I know that they've got access for looking at VirtualBox.
With you sharing out your VMs to multiple analyst stations, do you run into any licensing issues with Windows?
So the question was, with sharing out these VMs to multiple analyst workstations, do you run into licensing issues with Windows? That depends. If you've got a retail copy of Windows, you can pull it off of one system and put it on another with no problem. But I did some research into it, and because Nova Labs is a nonprofit, we can kind of get volume licenses of Windows, and it's basically like you get to license Windows. Not like Windows XP, Windows 7, Windows Vista, Windows 8. You can run any number of copies of Windows that you have licenses. So say, for example, if I get 15 licenses of Windows, I can have 15 copies running, no matter which ones at a time.
Use the federal version. It's open source and not free for 120 days.
Yeah, the comment was to use the FDCC disk images. Those actually have a really nasty EULA with them, where it says that you can't use them in a production environment, I believe. Or maybe it was, I'm sorry, the Internet Explorer VM images. Those, I think, also only last 120 days. But The IE browser ones, they say specifically, these are for Microsoft Virtual PC. If you convert the disk image into something else, you're exceeding the license. So I'm going to try to get a whole bunch of copies of Windows for Nova Labs and then let people do things there locally. Question?
I was kind of curious as far as the de-duping of the memory. Have you had any problems with muddying of memory or being able to shove information from one memory space to the next because of an error or an artifact of the de-duping process?
So the question was, with the memory deduplication, is there any way to, I guess, poison one virtual machine from another because it's all been merged together? As far as I know, not really, because it's going through and it's in memory, it's copy and write, it's read, copy, update. So as soon as one virtual machine that currently has similar memory tries to change that, the kernel says, wait, hold up, I need to allocate a new page for you, and you go there now. So that is safe as far as I know. Thank you.
Were you using huge pages at all with the base hypervisor system?
So the question was, are you using huge pages under Linux with the base hypervisor system? Huge pages and KSM, kernel same page emerging under Linux, are actually mutually exclusive. You can't use them. It's actually a performance benefit if you have a lot of virtual machines that you're running at once, but unfortunately you can't use KSM. Any more questions? Oh, over there on the left.
Have you thought about using, so say you've got two VMs and you deduplicated the memory, could you use then the fact that one of those VMs is now changing something in that deduplicated memory area as like a change detection or malicious behavior detection indicator?
So the question was, can you run two virtual machines at the same time, have one, I guess, as a clean system and then another as the infected system? You could do that, but what I would probably do instead is pre and post infection, dump the memory off, and then do some comparative analysis with that. I actually was doing that with the volatility framework. I basically had the list of plugins volatility can use and ran all of them against the memory dump, and then did a just plain text diff of those plugins later. And that was actually how I found the Word document that injected a new thread into Explorer. Anything else? Nope. Okay. Thank you, folks.
Short break. Next talk in 20 minutes at 3 o'clock.